Welcome back to Pipe and Skill, and today we are doing low carbon steel. Some people call it malleable iron. The size we're going to use today is 1/2 inch. We're going to cut it, put a thread onto it and prepare it the right way and use a couple of different types of thread sealing agents for the threads. So low carbon steel is normally used in factories, schools, colleges, anywhere where there's high traffic and there's a chance of it getting damaged. Low carbon steel is probably one of the cheapest materials that plumbers use to buy. One of the materials that's a lot harder to work with because of the cutting and threading involved in it and the bending. It leaves a lot more sort of heavy duty tools. Again, with most plumbing sort of materials, we can have a wide range of fittings we can use, and there's probably just a bit more on low carbon steel because it is more difficult to work with. We've got a 3/4 inch elbow next to the 1/2 inch elbow, and the big long one that looks like a 1/2 inch elbow, but it's a longer sweep on it. These are called swept elbows. You use them maybe in old-fashioned one-pipe systems, or just if you want to sort of not restrict the flow rate as much as possible. We have also, again, all the range of T pieces, from the 1/2 inch equal T to the 3/4, 1/2 inch T. We've got a 3/4, 3/4, 1/2 inch T. And this one, the sort of silvery looking one, is a swept T. That lets the water flow around where you want it to go. If I was going in that direction with the flow rate, I wouldn't put the swept T facing that way. It would be pushing the water back upstream. So when you're using a swept T, you always try and put it on at the same sort of direction as the flow rate you want it to go. And this is like a knuckle T piece, so they're slightly different. This one's obviously a lot smaller. The water will flow in the direction that you want it to go in, hopefully. This one just helps it a little bit. Now this one's more silvery than that one, is because this one's been galvanised, which means any sort of potable water, wholesome water that you're using, you would always try and fit the galvanised T pieces on elbows or even pipe. We've also got a range of straight couplings. We've got these ones here are called barrel nipples. You can buy them in different lengths, or if you have a big pipe threader, you can make them to whatever size you want. This one is a hex nipple. We've got a sort of hex nut on it. It just means it's easier for us to tighten or to hold on to or to grip. We have caps. We have 3/4 to 1/2 inch bushes, inch and a quarter bush to 1/2 inch bush. So there's always a way of reducing or getting bigger or extending with all these low carbon steel fittings. This one here, we have a T-piece that's cut open, and we can see where the pipe comes in just past the thread and then stops. This gap in the middle is obviously so the gas or the water can flow through, and normally that measurement from the inside, or full slip as we like to call it, to the end of the thread is normally about 1/2 inch, which is 12.7 millimetres if you're in metric. So now we're going to cut the pipe on a thread. Now, when we do things on these videos, they're normally aimed at level 1, level 2 students, or someone who's just starting out in their plumbing career. I do things a bit differently from what's on site, but it's to get the basics of the knowledge in, and then at a later date, all plumbers do things differently. We know that. So then, if they've got the basic knowledge of what to do it, they'll find an easier way, or a newer way, or a way it's more easier for them to do it. So the first thing we're going to do is going to measure a piece of pipe. I'm going to measure a piece 200 mil. Now, because I've been doing this for quite a long time, I could probably cut quite a straight cut and go right through the pipe and then thread it. If you're not confident using a hacksaw or when you're cutting it, we also get the students to use heavy duty pipe cutters. The same as the old-fashioned monument cutters, but different from the pipe slices. We've got a cutting wheel and the 2 rollers again. So I'm having the cutting wheel facing me. I put that on the mark, and then I tighten it up with the handle, and it's quite loose. So again, when I sort of tighten the handle, it pulls the cutting wheel in and makes a groove in the pipe. What we're going to do is we're going to go maybe 3/4 of the way through. We're going to try and guess it, and then we're going to cut through. If I cut right through with the cutting wheel, what happens is I get that burr on the end of the pipe again. So we tell the students, go 3/4 of the way through, and then cut it, use the last bit for the hacksaw. And the difference is, this one here is the one that's been cut with the pipe cutters, and this one here is the one that we've cut halfway through and then cut with the hacksaw. And you can see there's a slight restriction on the flow. That would mean I would have to file out the burr on the one I've done with the pipe cutters, which would probably take me longer than me just sort of hacksawing through. So again, I put it on, quarter turn it. I don't want to go too far. With this one, I won't crush the pipe but I'll probably end up breaking the heavy duty pipe cutters. And I go round and I make sure that the wheel has cut a groove in the pipe. So I keep going, then it starts to become loose. That means the groove is getting to that depth I want. When that happens, don't try and do it 2 or 3 turns to be quick. A quarter turn again and just twist it round. And all you're doing is bit by bit until I can guess for halfway or 3/4 of the way through. Again, I'm trying to make sure I'm not going to go right the way through because then I need to spend time with a file and deburr the pipe. Last one. And then I'm going to move on to the hacksaw. Obviously, if you're a plumber and doing low carbon steel for a long time, you would just cut it. Now, I let the students follow that groove I've put in the pipe by using the hacksaw. Again, finger on the blade. Not only do they get a nice straight cut with it, they're not hacksawing for a long time. So I'm using all the teeth. Just take your time. And then I'm listening for the tone to change. When the tone changes, I know I'm nearly the way through it, and then I've got to pay attention. There's the tone changing, and then hold the pipe. That's it cut. I've got a perfectly nice straight cut, and we're ready to thread it. So I put that pipe here. I don't want to be too close on the pipe vise. I want to give myself a bit of room for when I'm using the hand dies. So bring the pipe through a bit. Under this box, we've got a set of dies, the Rothenberger. If I open it up, I have the handle, I've got the stock head. So I screw the handle into the stock head, and on this box, I've got 1, 3/4, and 1/2 inch dies. So I'm going to use, obviously, the 1/2 inch one as a mark on the very end. It tells me which one it is. And then click it in. So this is me ready to put a thread on the 1/2 inch low carbon steel pipe. But first, I've got to put some cut and paste. This just sort of helps lubricate it and cool down the metal because there's quite a lot of friction. It's like a paint. All I do is put a bit on the end, paste it, and then we're ready to cut the thread. This is the difficult bit, or the bit that requires a bit of work. Make sure the vise is tight. Make sure I've got a bit of room between the vise and the handle so I don't bang my hands off the bench. And it goes in one way. There's a sort of stock on it that holds it straight and then up to the thread. If I try and put it on the wrong way around, it doesn't go. I can't get anything done. So there's only one way it fits on. And then I need to look on for the arrow. On this button here, it works on a ratchet system. So at the moment, this is me putting the thread on. So it goes from left to right as I'm looking at it, and then ratchets back, down again, and then ratchets back. When I've made the thread, I turn the ratchet or the arrow anti-clockwise or right to left, and then I take it back off the same thread that I've just made. So obviously I'm putting the thread on, so I get the arrow, I point it clockwise, left to right, and now I've got to push with my left hand and then wind it with my right. The way I do it, the palm of my hand on the head of the stock, I can use a cloth piece of paper that I've got just to protect my hand, or I can just do it. So now I've got it, so I'm putting my weight against it, I've got my elbow jammed into my hip, and as I'm turning both of them at the same time, hopefully I should be cutting the thread on. I've got to wait, I can feel it sort of biting, and then I'm putting the thread on. I don't want to take the pressure off too early. If I do that, I chip off the first thread, and then I sort of chamfer the end of the pipe, and then it's a bit of a nightmare to start cutting again. I've got small windows that I can look through, and I can see I've got 2 or 3 threads already started. So once I've done that, I can take that hand off, and I can use a bit of body weight. All the students we get, if they're left-handed, they find it more difficult. Their natural inclination is to go on this side, and it's like doing some sort of weight sort of circuit to do. So they're always pulling up, and they get tired a lot more quicker. If you're right-handed, all you do is straighten your arms and use your body weight. When it starts to get a bit tight, that's just the threads that are gunking up with the threads that you've just cut. It's good practice to reverse it a couple of turns, change the button again. You can see the shavings falling out. That cleans the thread for you. Once that's come out, turn the button back clockwise again, and you keep cutting the thread. Now, the amount of thread you need to put on is around about 1/2 inch. And the reason for that is that's how much goes into the fittings. The thread's also called a taper thread, which means it's at a slight angle as it comes down. The fittings are parallel. So when you naturally tighten your pipe into the fitting, it jams in and it means you get a better fit and it makes it a bit tighter as well. There's less chance of it working its way loose. So I'm not going to take it off every couple of minutes and then measure the thread. What Rothenberger Rigid and all the sort of thread makers have done, when you get to the end of the pipe, comes out the head of the stock, that's enough thread you've done. So if I keep going for a minute, again, use my body weight, pushing down. This all takes a bit of time. This is why no one likes doing low carbon steel. But if you're an apprentice and you do a lot of work with this, you'll be standing at a vise all day and the tradesmen will be bringing you pipe and you'll be cutting and threading the pipe for them. So I'm nearly at the end. And I can just see the pipe coming out to the very edge of the stock. So I know that's making enough thread onto it. Remember, there's quite a bit of heat in that just with friction. So then when I get to that sort of stage, I turn the button back. So I'm coming back off the thread. And then I come back off the thread that I've just made. Then I can wind it off. Comes off, clean the head on the bench, take a rag, and now I just make sure it's nice and clean. If I take it out of the pipe, I can see right away there's one thread that's chipped. That doesn't matter. Once I start using the pipe sealer on this, that'll be absolutely fine. So now I'm going to use a fitting. I'm going to put it together. So I've got this on, and I'm going to use a 1/2 inch T-piece. So this is a 1/2 inch T. If I'm not too sure about the thread, I can just check it with the fitting, make sure it all fits on, which it does. So I'm happy to go. Now, in the workshop, we'll use for this PTFE tape. And there's a reason for that. We don't use paste and a lot of flux. We try and keep it to a very bare minimum. Because we reuse the fittings, if we used paste and hemp, which I'm going to show you in a second how to do it, these fittings would end up just covered in paste. The benches would be covered in paste, and we'd be covered in paste. So we talk about them, we show the students how to use it, but we just use PTFE because we're only going to test it once or twice and then take it apart. So if I do the PTFE tape first, now I'm going to go from, in the same way as the thread, I'm going to go from left to right. I come off the bottom of the roll because if I come off the top, if I show you what happens, if I put the PTFE tape on it and wrap it, as I'm going round, it's unravelling at the same time. I end up really moving massively and I'll end up dropping the roll of tape. So when I'm doing this, always off bottom of the tape, I'm going left to right with the thread. I can hold it, I wrap it round, I catch the end, and that means I've got a bit of tension on the tape and I can put it exactly where I want it. I always try and leave maybe the first thread without any tape on it, just so the fitting starts a lot easier. And I'll probably go round about 14, 15 times if I'm counting. But eventually you would know how much. You break the end off, just over with your hands, make sure it's all okay. And now I'm going to put the T-piece on. Again, I've not got it on that first thread, so I get it to start okay, and then I use a pair of heavy duty Stilsons. These only really work one way, they work like a vice. When I push the weight on the handle, I make that gap smaller, which in turn grips the fitting. What I don't want to do is put the Stilsons on the top of the fitting where the thread is. If I'm putting a lot of pressure on that, I could squash the fitting and misshape it, which means I can't get the other piece of pipe in. But on the fittings, there's an edge on it. It's a sort of slightly raised edge. I can put the Stilsons on that. Again, I'm going left to right. So I'm putting the weight on the handle, it's closing the jaws and it's biting hard onto it. And that stops it from slipping. If I try and do it the other way, and I put it on, when I push the handle, I pull it, that opens up and it comes off. So really, they only work really well one way. Again, how tight do we go? I would push it round. It's more practice than judgment. You eventually know that it's tight. If I'm jumping on it, it's probably too tight. If I've just got a bit of force behind it and it's quite tight, I'm judging it. In the workshop, we get the students to test it. If it's not tight enough, they come back, tighten it again, and they find out their own way how tight these fittings should be. So that's me put a T-piece on with PTFE tape. If I leave this pipe to the side, to make it easier for me to show you, I've got a piece of pipe that I'm going to put on the top bit of the T-piece. I've just put that in the vise at the moment. And I'm going to use a thing called Hemp. This is what I was taught to use when we did low carbon steel. I'll go through some of the other sort of materials we've got there. You grab a piece of hemp, you peel it off. This is actually horsehair. I can thin it out a bit if I want, and then I'm going to put it on. I can put it on dry the thread and wrap it round, but then we've got to use some jet blue. This one's called jet lube. All it is a liquid PTFE tape paste. There's a couple of different names in the market. This is the stuff we can't use in the workshop. If we put this in all the fittings, it'd be absolutely everywhere. Also, we don't really put it on compression olives either. Same sort of thing again. We don't use the olive again, but we use the fitting. So the less of the stuff we use, the better, and then we get reuses out of the fittings. So I put a bit on the thread, just smear it on, then I get my hemp. The first thing I do with the hemp is I come down the thread and hold it on, and then I can wrap it round. Again, when I get round, that holds it tight for me. I've come back over the top with a piece of hemp that I've put on, and then we just wrap it round in the thread. You get to the end, if it's too long, pull that off. Now I think I was told one of the advantages of using the hemp was, other than the PTFE tape, if I've got a really, really small leak, or it's just sort of sweating, it's not dripping, I can just see it's leaking. Instead of me stripping it all back out, the fibres in the hemp swell up and hopefully take up that gap and stop it leaking. I don't know if that's true, but it sounds good, it makes sense. I get a bit more paste, I put that on top of the hemp. We're really lucky now, we've got these wee brushes. Years ago, it was just, you smear it on with your finger, clean it off. I can take this back out the vise. I put the bit back in, I'm going to put that pipe onto the T-piece. And then I wind it in. I do it hand tight again. Again, this is why we use the Stilsons. The Stilsons, when I put pressure on the right way, the jaws clamp, so I can actually put it on a round surface on the pipework. Once that's tight, and then I can tighten it up. Again, I'm just guessing how tight it's going to be. Bit more, the more you do, the better you find it. And sometimes, if the thread's long enough, I've got a couple of threads shown at the top. So that's tight. The next thing I'm going to use, if I take this out of here, is the PTFE tape on a sort of roll. It's more like a thread, looks a bit like dental floss. All I'm going to do is, again, I've got to go left to right again in the way of the thread. If I go against the thread and wrap it on, when I put the fittings on, it seems to take it off. Again, we could have a leak. So I get the Loctite tape, and I can actually wrap it inside the thread, put a tension on it again. I can run it up as far as I want. If I want, I can come back down the thread, or there's a cutter in there, just like you get in dental floss. And then I can put that in the T-piece. And again, that should do the same job as the PTFE tape or the hemp. Again, get the Stilsons on, and wind it in. And that comes off. Now with this stuff, as you're an apprentice, my job would be on a Friday, would be go around all your jobs and take off any hemp or PTFE tape that you could see. Because when the painters come in to paint it, they wouldn't like painting on top of this sort of stuff. So either you're doing your hacksaw for it, or some people preferred a hacksaw blade. That just makes it nice and clean. And obviously it doesn't matter what's coming off the outside, because the bit you want to seal it is actually on the thread. And then you can do the same with the PTFE tape. That'll be your Friday afternoon job as an apprentice, to go back down all those fittings and clean them all off, getting ready for the painter. The next one we're going to use, if I move this through a bit, is one of these. We've got a thread seal liquid, and we've got rapid blue thread set. And this one we're going to use, if you take the lid off, you click it open, and you can put a bit on the thread. Smear it in the threads all the way around. I'm going to grab this 1/2 inch 90-degree elbow, and I'm going to wind it on. Now, according to the instructions, that sets like a sort of thick sort of glue. Again, I wind it on, but remember the thread's got a tapered thread and the fittings are parallel. So again, it naturally gets tight the more I tighten it. And that's that done. So a bit more. Put the tools down. So T-piece and an elbow, we've got PTFE tape, we've got hemp and paste, and we've got the thread seal that looks like the dental floss, the Loctite stuff. And And then we've got the Rapid Blue, like a glue that just fits on the thread. All these materials we've used are VAS approved, so you can use them on drinking water, central heating water, or whatever, and we should be fine. Can you imagine using this stuff in here? Can you imagine where it'd be?